Let's dive into your project with a strong start. First and foremost, I recommend saving your project immediately. This simple habit keeps your work organized and safeguards against any unexpected data loss. Now, let's get into creating your components. For this project, you'll be working with two essential parts, a Hexnut and a bolt. Right-click in your browser to create them. Since this isn't a sheet metal project, choose the standard type. We'll be using a top-down modeling approach, so selecting internal is the way to go. Naming your components clearly is crucial. It makes everything easier to manage. Your top-level component will act as the parent, which is perfect for our setup. Typically, you'd leave the Activate option checked to start working on your new component immediately. However, since you're creating both components right from the start, you can leave Activate unchecked for now. This keeps you in the main component, making it easier to manage your initial setup. Once you click OK, your bolt component will appear in your browser ready for you to start building. This organized approach sets a solid foundation for the rest of your project. Imagine the small anchor symbol as a sign that this component is firmly attached to the parent component, much like a rigid joint. While you won't need to worry about this for our project, I thought it would be useful to mention in case you were curious. Every action you take is recorded in the timeline of the active component. This handy feature allows you to easily navigate through your model's history. Just ensure you're working in the correct component to keep everything organized and aligned with your plan. We'll start building our 3D model from a sketch. I'm creating a bolt that will stand upright, so using the horizontal construction plane is ideal. You have several polygon options, but I suggest using the top two since they let you create a polygon from a central point. Using the origin as your center point is particularly helpful because it provides a consistent reference, which you'll see in action later in our project. You can size your polygon any way you like, but it's important to understand what the measurement represents. The distance from the center of the polygon to its side. Notice the blue infill? That means our sketch is closed and a polygon constraint has been automatically applied. Change the length of one side and all sides will adjust accordingly. Now, here's a time-saving tip. Instead of exiting the sketch before making your next move, go straight to the next step. For instance, if you press the E key, you'll exit the sketch environment and jump directly into the extrude command. For this example, I'll set the height to 10 mm, but feel free to experiment with different dimensions. We need a closed profile that starts from the profile plane extending 10 mm without the taper angle. This setup is perfect for creating a new body within our active component. You've built the foundation for your first component. Great job. Before we move forward, it's a good idea to save your work. This way, you can always return to this version if needed. When I hit save, it still says V1 version 1. But as soon as we start the next step, which is sketching, the file will update to version 2. Let's dive back into sketching our bolt component. This time, we'll use the face of the component instead of a construction plane. This approach lets us sketch exactly where we want the next part of our design. For this part of the design, we need to create a circle. It's a good habit to use keyboard shortcuts to speed things up. By pressing the C key, the circle command becomes active, which you'll notice by the blue highlight behind the circle icon in the toolbar. Remember, I asked you to center your polygon above the origin. This is the second time we're using the central point over the origin, ensuring that both our circle and polygon are perfectly positioned relative to each other. I'll give the circle a diameter of 20 mm, but feel free to experiment with other dimensions. You can always right-click your sketch in the timeline to edit it later. Any changes you make will update all subsequent actions in the timeline. To save some time, press the E key to activate the extrude command. For the extend type, we'll type a distance since we're not extruding through or to another object. We'll start at the profile plane where we made our sketch, with the direction being one-sided. The taper angle isn't relevant for our design here. Lastly, don't forget the operation drop-down menu. Autodesk Fusion suggests a join operation, which works for us since we want everything we've modeled so far to be included in the same body. But remember, there will be times when you'll need other options from this menu, so keep an eye on it. Your bolt needs a thread, which you'll find in the Create drop-down menu. The image shows an internal thread, but this tool works just as well for external threads. Our entire bolt will be threaded, but you can easily uncheck the full length option if you want to set a custom start distance and thread length. This thread is just a visual representation. If you want to 3D model the thread, which you might need to do if you're planning to 3D print it, you can check the modeled box. Keep in mind that modeling the thread makes your design more complex. While this won't be an issue for a small project like ours, it can slow you down on larger projects. So, unless you need a fully detailed thread for printing or other purposes, you can leave Modeled unchecked. Regarding thread type, size, designation, class, and direction, we'll just note that standardized options exist for these settings. However, we won't dive deep into those details for this project. By using the default settings, you'll still get a functional and visually accurate thread for your bolt. This approach keeps things straightforward and efficient, allowing you to focus on the overall design without getting bogged down in complexities that aren't necessary for this tutorial. Every action you take is recorded in the timeline below. This timeline is specific to the bolt component. When you move on to the Hexnut component, a fresh timeline starts, capturing your actions there as well. Now, as you begin sketching, it's important to utilize the bolt component. While we could create a new polygon, that would be a mistake and add unnecessary work since we want the Hexnut to match the size of the bolt exactly. Instead, let's make use of your original bolt sketch, which is conveniently located within the bolt component. To do this, go to the Create menu and select Project. The selection filter allows you to choose whether you want to project from the sketch or the body. By using the projection link, you are ensuring that any changes made to the original sketch or body will automatically update to projection. This is especially useful if you ever decide to adjust the bolt size, as the Hexnut will adjust accordingly. Now, you'll see a polygon sketch on top of the bolt. The purple color and the projection symbol indicate that this is a linked projection. Next, activate the Extrude command by pressing E and create the extrusion. I'll measure the bolt to ensure the Hexnut matches perfectly in size. If you get an incorrect measurement, no worries. Just right-click and select Repeat Measure to correct it. We obviously need a hole in our Hexnut. Instead of just drawing a circle and cutting it out, we're going to use the Hole command, which you'll find in the Create drop-down menu. It's a good habit to use keyboard shortcuts whenever you can, so I'll go ahead and activate design shortcuts by pressing S and searching for Hole. Now, while the quickest way would be to press H for the Hole command, searching is a great backup if you ever forget the shortcut or haven't learned it yet. We need to position this hole correctly, and once again, we'll align it with the central point at the origin. It can be tricky to spot the origin behind all the other components, but here's a tip. Press and hold the left mouse button to reveal a menu, then select O to move your hole to the origin. For quality assurance, it's always a good idea to check your work from different angles. While the Hole command might look perfect from the top view, a different perspective could reveal some issues, like accidentally cutting into parts of the design that you want to keep intact. We certainly don't want to cut through our red parts. To fix this, you can adjust the hole settings. Changing the extend type to all isn't helpful here because it would drill through the entire bolt component. Instead, I'll set the depth to match the thickness of the Hexnut. In some cases, you might prefer to link the depth to another object so it updates automatically, but that's more advanced than we need for this basic tutorial. As for the hole type, let's go with the threaded hole matching the settings of your external bolt thread. Everything's looking good so far, so let's continue refining the design. In the Modify drop-down menu, you'll find a wide range of commands to tweak and refine your design. As you might expect, the Create drop-down is where you build your components, and the Modify menu is where you fine-tune them. One useful tool here is the chamfer tool, which lets you remove material from your edges. To get started, select the edges you want to chamfer. If the distance value window gets in your way, no problem. Just press and hold your mouse button until a small hand appears, allowing you to pan around your workspace and get a better view. As you select more edges, keep an eye on the bottom right corner of the canvas. You'll see the number of selected edges update in real time, so you can be sure you're working on the right parts. Once you've made your selections, go ahead and add a distance. But don't stop there. There's more to the chamfer tool than just setting a distance. For example, you can experiment with the blend corner type, which I think will give our Hexnut a nice smooth finish. If you prefer a different look, like a sharper edge, try the chamfer or miter corner types. The key takeaway isn't to memorize every corner type, but to stay curious and explore the different options available in various command environments. Once you're happy with the settings, press OK. Personally, I think the Hexnut is looking even better than the bolt, so let's apply the same chamfer to your bolt and keep that sleek finish consistent. Before you dive into any work, make sure to activate the component you intend to work with. This is crucial, especially if you're planning to tackle more complex projects down the line. We're going to keep reinforcing the use of shortcuts. Instead of going through the Modify drop-down menu this time, I'll simply right-click and choose Repeat Chamfer. This saves time and keeps the workflow smooth. Now, go ahead and select all your edges. There should be 18 in total, which you'll see confirmed in the chamfer menu. We're going to stick with the same settings. A 1mm chamfer with an equal distance type and a blend corner type to give it that smooth, polished look. You can bring your components to life by working with either materials or appearances. Think of appearances as purely cosmetic. They're all about the look. Materials, on the other hand, not only change the look but also add physical attributes like weight and strength. In simpler terms, appearances handle the color, while materials bring in both the color and the engineering properties. Now, in this project, we're not diving into the engineering side of things, but let's apply a material just to get familiar with the process. Materials are organized in folders, and all you have to do is drag and drop them onto your component. You'll notice that many commands and workflows in Fusion are designed to be intuitive, so even if you haven't used them before, you can often guess your way through. Let's switch over to the Hexnut component and repeat the process with the Physical Materials command. I'm going to choose a sleek red metal, but you're welcome to explore the Fusion material library and pick whatever color and material you like best. It's time to bring your components together. To do that, head over to the Join command or simply press the keyboard shortcut J. Whenever a command has a shortcut, you'll see it listed right there in the drop-down menu. Before selecting your components, make sure to choose the correct joint type. For this project, we want our Hexnut to both slide and rotate around the vertical axis, making the cylindrical joint the perfect choice. When you start selecting components, remember that the first one you pick will move first. So, we'll select the Hexnut component first. As you can see, I made a mistake trying to place the joint exactly centered above the hole. Here's a pro tip to make it easier. Hover your mouse over the face while holding down Control if you're on a PC. This trick helps you snap right to the center with ease. You can use the same method when snapping to the bolt. Now, your Hexnut will reposition itself according to your joint, and you'll see the joint appear in the model. Next, let's talk about motion limits. You have two options here, rotate and slide. We'll start with the slide. You can set limits for how far the Hexnut can move. For instance, I'm setting the maximum slide distance to 50 millimeters, and you'll immediately see a demonstration of that limit. The rest position is where the joint will naturally settle. Since I set the slide limit to 50 millimeters, it rests there, but if I had set it to 25 millimeters, the joint would rest at 25 millimeters. The Hexnut moves deep into the model, so let's set the minimum slide limit to 0 millimeters. This is where we initially set the joint snap, meaning any positive value moves above that spot and any negative value below it. You can preview how both rotating and sliding limits will look by selecting those options. It would be more realistic and frankly more impressive if the joint rotated back once it reached the top. Let's make that happen. Find your joint in the browser and model, right-click it and choose Edit Joint. In the Joint Motion Limits options, go to the Rotate section. Once you activate the limits and set some degrees, you'll see an illustration of your settings right around the joint in the model. For this basic tutorial, I'll set the minimum rotation to 0 degrees and the maximum to 180 degrees. Make sure to check all limits before previewing. Now, the Hexnut rotates 180 degrees, pauses, and then returns 180 degrees backward. It's pretty mesmerizing to watch, but let's keep moving forward with our project. When it comes to renderings, you've got options. You can do them locally or in the cloud, and some are free while others might cost you. For this tutorial, we'll keep it simple and create an in-canvas rendering. First, switch your workspace to render in the top left corner. You'll be rendering exactly what you see on the screen, so it's a good idea to hide any elements, like joints, that you don't want to include in the final image. You can easily do this in the project browser by toggling visibility. To get started, right-click and open the scene settings. You'll notice that many of the settings and shortcuts feel familiar if you've used other computer programs before, like right-click, contextual menus, and various keyboard shortcuts. Rendering in Autodesk Fusion is straightforward. One of the basic settings you'll need to decide on is whether to use a solid color background or an environment. Simply drag and drop your preferred environment into the scene, and don't forget to change the background setting from solid color to environment to match. Adjusting the brightness, positioning, and other settings like shadows and reflections is intuitive and easy to grasp. If your chosen environment has lamps, you can easily position them in relation to your object using the rotation command under the position settings. There are, of course, more advanced settings you can explore later, but for now, we're focusing on building a broad skill set. We'll get into the more specialized features of Autodesk Fusion once you've got the basics down. You can start your render directly in your Fusion canvas using the In-Canvas Render feature. It's straightforward. Just press the In-Canvas Render Play button to begin. As the rendering process unfolds, you'll see the elapsed time and iteration number appear in the bottom right corner, while your image gradually takes shape on the canvas. If you want to increase the number of rendering iterations for a sharper result, just drag the little icon that looks like a cat here to the right. When you're happy with how everything looks, simply press the Capture Image button to save your rendering. Once you're happy with the settings, validate the first menu by clicking OK. If you'd like to rename your image, now's the time to change the image name and select your preferred file type. I'm going to save this project to my local computer, but remember, you also have the option to save your image directly to a project in the cloud. Our image turned out fantastic, especially considering this was a free rendering done with standard settings and completed in just a few minutes. And there you have it. You've successfully completed your Hexnut project using a top-down design approach. You probably recognized many of the commands from earlier, but we also introduced some new ones along the way. I believe the 3 key takeaways from this project are: first, stay organized. Think of it as an investment. Taking a little extra time at the beginning to set up your components properly, name them clearly, and switch between them as needed will save you time and open up more possibilities as your designs become more complex. Second, make the most of symmetry and preset design resources. In this project, we frequently returned to the origin, which allowed us to work quickly and maintain high quality throughout. And third, make smart choices. Instead of manually sketching out a polygon with lines and angles, we use the polygon command to speed up the process. If you ever find yourself needing a particular command, chances are that others have needed it too, so it's likely available within the software. Next time you're unsure if a command exists, take a moment to search for it. You can activate design shortcuts with the S key and see what's available.